Look at the ocean. Every drop of water you have ever seen, every ocean, every river, every raindrop, every glacier, every cloud, sits on the thin outer skin of this planet. And we think of it as endless. 70% of the surface. More than 1 billion cubic kilometers of water. So much that from space, Earth doesn't look like a planet of rock at all. It looks like a planet of water. Astronauts say the same thing, again and again. That the first thing to hit you, looking down, is the blue. Not the land. Not the clouds. The water. It wraps the planet like a skin, filling every basin, drowning most of the surface of the world. We named our home Earth after the ground beneath our feet. But a visitor from another star would almost certainly have named it after the water instead. This is the ocean planet. And we treat that water as the whole story. We add up the oceans, the ice caps, the lakes, the rivers, the rain, and we think we have finally counted all of Earth's water. But we have only counted the water that catches the light. The water you can see is the exception. Most of this planet's water spends its entire existence in the dark, in places no human has ever been, in a form you would not even recognize as water at all. But here is something almost no one knows. All of that, every ocean on Earth, may not even be the biggest body of water on this planet. Because hundreds of kilometers beneath your feet, locked inside solid rock, there may be an ocean, or 2, or 3 oceans worth of water, hidden inside the Earth itself. Not a cave. Not an underground lake. Something far stranger. And we only proved it existed a few years ago, from a single, broken diamond. This is the story of where Earth's water really is. And by the end of it, the ground beneath you will feel very different, because you'll understand that you are standing on the lid of the largest reservoir of water in the known universe, and that it may be the only reason you are alive to hear this. We are going to follow the water. All the way down. And on the way, 3 mysteries will pull us deeper. First, how a small, worthless, broken diamond, spat out of the ground in Brazil, became one of the most important gems in the history of Earth science. Second, whether the oceans you know are quietly draining into the planet right now, and whether the sea itself could one day begin to vanish. And third, the oldest question of all, where did any of this water come from, and why does Earth have it, when the worlds on either side of us are bone dry and dead? 3 questions. 1 journey, straight down through the body of the planet. And by the time we climb back to the surface, you will have the answer to each of them, and you will never look at a glass of water, or the sea, or the ground beneath your feet, in quite the same way again. But to understand where it's going, we have to start with a number that sounds impossible. Ready? If you gathered every ocean, every sea, every lake and river and ice cap on the surface of the planet into a single sphere, that ball of water would be about 1,380 kilometers wide. It sounds enormous. But next to the Earth, it's tiny, a small marble resting against a basketball. All the water you have ever known is a thin film, barely wetting the surface of a giant ball of rock and metal. And now shrink it further. Of that little marble of all water, almost all of it, over 97%, is salt water, locked in the oceans. Pull out just the fresh water, and the sphere collapses to a fraction of the size. Pull out the fresh water that is liquid, and not frozen solid in the ice caps, and it shrinks again, to a tiny bead. Every lake, every river, every drop of drinkable water on the surface of the Earth would fit into a ball just a few hundred kilometers across. That is how thin the margin is. The water that all life on the surface depends on is a whisper-thin film, a rounding error compared to the mass of the planet. And for the whole of human history, we believed that film was the sum total of Earth's water. We had no idea that we were standing on top of something vastly larger. For most of history, we assumed that was all of it. that the water sat on top, and the rock below was dry. We were wrong. Because the water does not stop at the sea floor. It keeps going. Down. The first place it hides is closer than you think. Right beneath the ground you walk on. Beneath the surface, soaked into the pores and cracks of the soil and rock, is groundwater. And there is far more of it than most people imagine. Underground, hidden from every map, there is more fresh liquid water than in every river and every lake on the surface of the planet, combined. Many times more. Entire hidden seas of fresh water sit inside the rock beneath the continents. The Agala Aquifer, under the American plains, holds enough water to flood the entire United States a meter deep. Beneath the Sahara Desert, the driest place many people can imagine, lies one of the largest reserves of ancient groundwater on Earth, rain that fell when the desert was green, sealed underground for tens of thousands of years. There is a desert sitting on top of an ocean. And some of this buried water is almost unimaginably old. When you drink from a deep well, you may be drinking rain that fell before the first cities, before farming, before written language, water that has been sealed underground for tens of thousands of years. We call it fossil water. It fell in a wetter age, soaked into the rock, and has been waiting in the dark ever since, a liquid memory of a different climate. But the oldest water we have ever found makes even that seem young. Deep in a mine in Canada, nearly 3 kilometers underground, scientists tapped into pockets of water trapped in the rock, and when they measured its age, they were stunned. That water had been sealed, untouched, for over 1 billion years. Possibly 2. It is the oldest water ever discovered, older than complex life, isolated since a time when the surface world would be unrecognizable. And here is the detail that stays with you. The scientists tasted it. They described it as intensely salty and bitter, far saltier than the sea. A mouthful of water older than animals, older than plants, brought up from the deep dark of the crust. And even that ancient water is still not the hidden ocean we are looking for. To find that, we have to leave the crust entirely, and go somewhere water has no business surviving. And that is just the beginning. Because the groundwater is only the shallowest hiding place. To find the real hidden ocean, we have to go far, far deeper, into a place no water should be able to exist at all. 10 kilometers down. Then 50. Then 100. The rock gets hotter and denser, and the pressure builds until it could crush steel. This is no place for water. And yet, incredibly, the water is still here, not as a liquid, not as a river, but as something much harder to picture. 410 kilometers beneath the surface, we reach a hidden boundary inside the mantle, a place called the transition zone. And this is where the story explodes. Because down here, the rock is made largely of a mineral called ringwoodite. And ringwoodite has an astonishing property. Its crystal structure can trap water, not as liquid, but bound directly into the mineral itself, water molecules woven into stone. Here is how it works. Deep in the transition zone, the pressure is so extreme that ordinary minerals collapse into new, denser forms. Ringwoodite is one of them, the high-pressure version of the green mineral olivine, squeezed into a tighter crystal. And in that crystal, there are tiny gaps, defects in the structure, exactly the right size to catch and hold the pieces of a water molecule. The rock doesn't fill with water like a sponge. It bonds the water into itself, atom by atom, at the level of the crystal. Now scale that up. The transition zone is not a thin seam. It is a shell stretching from 410 to 660 kilometers down, wrapping the entire globe, a layer bigger, by volume, than all the oceans and all the continents combined. Fill even a modest fraction of that colossal shell with water-bearing ringwoodite, and the math becomes almost hard to believe. In laboratories, scientists recreated these crushing conditions and watched synthetic ringwoodite soak up water, confirming, in a machine on a benchtop, that the deep rock could act like a planetary sponge. The theory was solid. The chemistry worked. But a theory is not a discovery. To truly know the hidden ocean was real, someone needed to hold a piece of it. And no one ever had, because nothing comes back up from 400 kilometers down. Almost nothing. A single crystal of ringwoodite can hold well over 1% of its own weight in water. That doesn't sound like much until you realize how much ringwoodite is down there. The transition zone is a shell hundreds of kilometers thick, wrapped around the entire planet. If even a fraction of it is as wet as that one crystal, then the amount of water trapped inside it is staggering. Some scientists estimate it could equal all the water in all the surface oceans. Others think it could be 2, or even 3 times more. Sit with that scale for a moment. We are not talking about a hidden puddle, or a buried lake, or even a hidden sea. We are talking about the possibility that the largest body of water on planet Earth is not the Pacific Ocean. It is a layer of wet rock 300 kilometers beneath the Pacific Ocean, holding, perhaps, more water than every ocean, sea, lake, glacier, cloud, and raindrop on the surface, put together, several times over. If that estimate is right, then everything we thought we knew about water on this planet is upside down. The oceans we sail and swim and fish and fear are the minority. They are the small water. The main event has been hidden underground the entire time, and we walked over it, and sailed across it, and never suspected it was there. For years, that was the boldest claim in the field, and its harshest critics said the same thing every scientist says: show me. Show me a piece of it. Read that again. There may be 3 entire oceans worth of water hidden inside the rock beneath your feet, more water inside the earth than on top of it. And for years, it was only a theory. A calculation. Something the numbers allowed, but no one had ever seen. Until 2008, when a diamond fell out of the sky in Brazil. In the shallow river gravels of a place called Juína, in the heart of Brazil, diamond hunters pulled up a small, ugly, brown diamond. Commercially worthless. Cracked and included with flaws. The kind of stone a jeweler would throw away. But this diamond had come from deep, hundreds of kilometers down, blasted up from the transition zone itself by an ancient volcanic eruption. And sealed inside it, in one of those worthless flaws, was a tiny grain of a mineral. When a scientist named Graham Pearson finally analyzed that grain, in 2014, he realized what he was looking at. It was ringwoodite, the first piece of natural ringwoodite ever found on the surface of the Earth. And it was wet. That single grain, delivered to the surface inside a diamond, was over 1% water by weight. It was direct, physical proof, held in a human hand, that the transition zone is soaked with water. The hidden ocean was real. We had a piece of it. One broken diamond, thrown up from 400 kilometers down, confirmed one of the biggest discoveries in the history of Earth science. There is an ocean inside our planet. And it changes everything about how we understand this world. And the diamond was not the only proof. At almost the same time, on the other side of the world, scientists were listening to earthquakes. As seismic waves pass through the deep mantle, they slow down when they move through rock that contains water. And when researchers mapped the waves crossing the transition zone beneath North America, they found exactly that, a huge region where the waves dragged, as if moving through something wet. 2 completely different methods, a diamond pulled from a river in Brazil, and earthquake waves crossing an entire continent, pointed to the same impossible conclusion. The transition zone is soaked. The hidden ocean is not a local pocket under one spot. It appears to stretch, in patches, around the whole planet, a global layer of wet rock buried in the dark. When two independent lines of evidence, gathered on opposite sides of the Earth by scientists who weren't even working together, land on the same answer, that is when a wild idea becomes accepted fact. The Earth has a hidden ocean. It is not science fiction. It is one of the most important discoveries of the century, and almost no one outside of geology has ever heard of it. Now, a warning. This is where people get the wrong picture. When I say an ocean inside the Earth, forget everything the movies taught you. There is no vast cavern of dark water down there. No underground sea you could sail a boat across. No lost world with waves lapping on a hidden shore. The water in the transition zone is not liquid. It is not even really water as you know it. It is locked, molecule by molecule, inside solid, scorching hot rock, rock so hot it would glow, under pressure so immense it stays solid as stone. The ocean is a chemical ocean, woven invisibly through hundreds of kilometers of crystal. And that raises an obvious, dizzying question. If the water is trapped inside solid rock, hundreds of kilometers down, how did it get there? And can it ever come back out? The answer is one of the most beautiful and terrifying machines on Earth. Scientists call it the deep water cycle. And you already know half of it. You learned the surface water cycle in school. Water evaporates from the ocean, forms clouds, falls as rain, flows back to the sea. Round and round, forever. But that is only the shallow cycle, the part we can see. There is a second cycle beneath it. A far slower, far deeper loop, one that takes water from the surface ocean, drags it hundreds of kilometers into the Earth, holds it there for millions of years, and then, sometimes, sends it screaming back to the surface through a volcano. It begins where two of Earth's tectonic plates collide, and one plate slides beneath the other, diving down into the mantle. This is called a subduction zone. And the sinking plate does not go down dry. It is soaked, the ocean floor is cracked and waterlogged, its minerals swollen with seawater, saturated after tens of millions of years under the sea. As that wet plate plunges into the depths, it carries the ocean down with it, dragging seawater, locked in rock, deep into the body of the Earth. Every year, subduction zones pull an almost unimaginable amount of water down into the mantle, an ongoing, planet-wide drain that has been running for billions of years. The numbers are hard to hold in your head. Along the great trenches of the world, the deepest scars on the planet, waterlogged slabs of ocean floor are sliding into the Earth at a combined rate that carries the equivalent of billions of tons of water into the mantle every single year. It is one of the largest movements of water anywhere in the solar system, and it happens in complete silence, kilometers below the waves, where no one can see it. And we can actually watch it happen. Using earthquake waves, scientists can image these cold, wet slabs of old sea floor sinking hundreds of kilometers down, still carrying their cargo of water into the deep. Some of that water is squeezed out along the way, feeding volcanoes. But some of it makes it all the way to the transition zone, where the ringwoodite is waiting to catch it and lock it into the hidden ocean. This is how the deep ocean is fed. Drop by drop. Slab by slab. Over billions of years. And this is where one of our open questions turns genuinely unsettling. Because if the oceans have been draining into the Earth for billions of years, what if more water is going down than is coming back up? What if, very slowly, the sea is leaking into the planet? Some scientists have run the numbers, and the results are sobering. It is possible that the Earth is swallowing its oceans faster than its volcanoes return them, that over the next billion years or so, the surface of the planet could slowly, quietly begin to dry. We'll come back to what that would mean. But first, we have to follow the water the rest of the way down, and see what happens when the Earth decides to give some of it back. As the waterlogged plate sinks deeper, it heats up. And the heat begins to cook the water out of the rock, squeezing it free, like wringing out a sponge kilometers underground. That freed water does something extraordinary. It rises into the hot rock above it, and it lowers the temperature at which that rock melts. Water makes the mantle melt. And melting mantle is magma. This is the secret behind some of the most violent volcanoes on Earth. The great volcanic chains, the ring of fire that circles the Pacific, the peaks of the Andes, the volcanoes of Japan and Indonesia, are all built above subduction zones. They are, in a very real sense, powered by the ocean. The water that sank into the earth is what makes them explode. And these are not gentle volcanoes. The eruptions fed by subducted water are among the most violent on the planet. When water-rich magma rises toward the surface, the water inside it flashes into steam and expands with catastrophic force, the difference between lava that flows and lava that detonates. Mount St. Helens. Krakatoa, whose blast was heard thousands of kilometers away. Pinatubo, which cooled the entire planet for a year. All of them, powered by ocean water returning from the deep. It is a strange and humbling thought. The most destructive eruptions in human history were, in a sense, the ocean coming home, seawater that had been dragged into the earth millions of years earlier, finally forcing its way back to the surface, and taking a mountain with it on the way out. Water is not just the gentle thing that fills the sea. Deep inside the earth, it is the trigger. It is the fuse. So the deep water cycle turns out to be a kind of slow, violent breathing. The trenches inhale the ocean. The volcanoes exhale it. And the whole system has been running, breath after enormous breath, each one lasting millions of years, since long before there was a single living thing on Earth to feel the ground shake. And when they erupt, they release that deep water back into the sky as steam. Much of the water vapor roaring out of a volcano is ancient seawater, returning to the surface after a journey of millions of years through the inside of the planet. The volcano is the exhale. The subduction zone was the inhale. But this is breathing on a scale that breaks the human mind. A single breath of the deep water cycle, one journey of water from the surface, down through a trench, into the mantle, and back out through a volcano, can take tens of millions of years. Longer than mammals have existed. In the time it takes the Earth to complete one slow inhale and exhale of water, whole chapters of life on the surface begin and end. We live our entire lives inside a single held breath of this system and never feel it move. Every ocean you have ever seen is, right now, in the middle of a journey that started before your species existed and will end long after it is gone. The water is not still. It is falling into the earth and rising back out, constantly, at a pace so slow it looks, to us, exactly like nothing is happening at all. That is the strange gift of geology, to look at something that appears completely still, a rock, a sea, a mountain, and realize it is actually in violent, ceaseless motion, just far too slow for a creature that lives less than 100 years to ever notice. The earth is breathing water. Slowly, over geological time, in and out, down through the trenches, and back up through the volcanoes. And it has been taking these enormous, million-year breaths since long before there was anyone here to notice. But even the transition zone is not the bottom of the story. Because the water may go deeper still, far below the hidden ocean, into a place we are only beginning to understand. Below 660 kilometers, we pass out of the transition zone and into the lower mantle, the largest region of the planet, reaching down almost to the core. For a long time, scientists assumed the lower mantle was bone dry, that whatever water sank this far would have nowhere left to hide. Then, in 2018, another diamond arrived with another secret. This one, also from Brazil, contained a form of water ice, a type of ice that can only exist under crushing pressure, the kind found 600 kilometers or more beneath the surface. Ice. Deep inside a hot planet. It sounds like a contradiction, ice in a place hot enough to melt rock. But under that immense pressure, water can be forced into a solid state even while burning hot. This strange, dense ice, trapped in a diamond, was another message from the deep. Water reaches far below the hidden ocean, deeper than we ever thought it could go. This kind of ice even has a name. It is a high-pressure form of ice unlike anything that forms in your freezer, with its atoms packed into a dense, cube-shaped lattice that can only survive under enormous force. It had been created before, for split seconds, in laboratories. But finding it in nature, sealed inside a diamond that had risen from the deep mantle, was a genuine shock. It meant that liquid water, real water, must exist down there in the deep earth, at least long enough to be trapped and frozen as the diamond formed around it. And the discoveries keep pushing deeper. Some scientists now suspect that water, sinking with subducted plates, may react chemically with the rock all the way down to the top of the core, and that hydrogen from that water may even be dissolving into the molten iron itself. If that is true, then a piece of Earth's original ocean might be hidden not just in the mantle, but woven into the very heart of the planet, nearly 3,000 kilometers down. And some researchers now believe the water may not stop even there. That it may reach all the way down to the boundary with the core, and nearly 3,000 kilometers deep, where it could be reacting with the molten iron itself, in ways we are still struggling to understand. The deeper we look, the more water we find. It is threaded through almost the entire planet, from the puddles under your feet to the edge of the molten heart. Earth is not a dry rock with some water on top. Earth is wet, all the way through. Which brings us to the question that has haunted scientists for over a century, and the second thread we left hanging. Where did all of this water come from in the first place? Because the early Earth should have been dry. When our planet formed, it was a ball of molten rock and metal, glowing, bombarded, so hot that any water near it should have boiled away into space instantly. A newborn Earth was no place for oceans. So how did a burning, dry rock become the blue water world we live on? For decades, the leading answer was simple and dramatic. The water came from space. It was delivered by comets and by water-rich asteroids, millions of them, slamming into the young Earth over hundreds of millions of years, each one carrying a little cargo of ice, slowly filling the oceans drop by frozen drop. It's a beautiful idea, that the water in your body, in the ocean, in the rain, fell from the sky as ice inside comets, older than the sun. And part of it is almost certainly true. Some of Earth's water did come from space. But when scientists checked the fingerprint, the exact chemical signature of the water in comets, and compared it to the water in our oceans, something didn't match. The water in many comets is subtly different from the water in the sea. Comets alone could not have filled the oceans. Part of the water had to come from somewhere else. We know this now with real precision, because we went and checked. In 2014, after a 10-year chase across the solar system, a European spacecraft called Rosetta caught up with a comet, a dark, icy mountain called 67P, and measured the exact type of water frozen inside it. If comets had filled our oceans, the water on 67P should have matched the water in the sea. It didn't. It was strikingly different. One more piece of evidence that comets were not the main source of Earth's water. The better match came from a different kind of object, a class of dark, primitive asteroids, left over from the birth of the solar system, that are surprisingly rich in water bound inside their minerals. Their water fingerprint looks much more like the water in our oceans. So the picture shifted. Much of Earth's water may have come not from spectacular icy comets, but from humble, water-soaked rocks, the same kind of material that built the planet in the first place. And that is the clue that points to the strangest possibility of all. If the very rocks that assembled into the Earth already had water locked inside them, then the water was never really delivered at all. It was part of the recipe. It was here from the first day, mixed into the batter, and the hidden ocean deep in the mantle may be the direct descendant of that original, primordial water still trapped where it has always been. And that somewhere else may be the most astonishing answer of all. Because the discovery of the hidden ocean, the water woven into the deep rock, hints that the water was here all along. That the rocks and dust that came together to build the earth were not completely dry. That they carried water inside them, locked in their minerals, from the very beginning. If that's true, then the earth was born wet. The water didn't arrive later, as a gift from the sky. It was baked into the planet from its first moment, and then, over billions of years, slowly sweated out of the deep rock, rising through volcanoes to pool on the surface and become the seas. The oceans didn't fall onto the earth. They came out of it. The hidden ocean inside the mantle may be the leftover, the reservoir that never made it to the surface. The source the seas were poured from, still holding, even now, more water than it ever gave up. And that changes how we see the water on the surface. The ocean is not a permanent fixture. It is the visible tip of a deep, slow, planet-wide system, one that has been filling and draining for 4.5 billion years, and that is still running right now, beneath your feet, whether you feel it or not. Which finally brings us back to the most unsettling thread of all. If the water is constantly draining into the earth, could the oceans one day run out? The honest answer is, possibly. Over an almost incomprehensible span of time, hundreds of millions, or billions of years, the balance between the water sinking down and the water rising back up may slowly tip. If subduction keeps pulling more water into the mantle than the volcanoes return, the surface oceans could gradually shrink. Sea levels falling not by meters, but by kilometers, over the deep future. The continents growing. The blue slowly draining out of the blue planet. Imagine an Earth, hundreds of millions of years from now, where the great oceans have shrunk to scattered seas, where the Pacific is a basin ringed by exposed sea floor, and the coastlines we know are buried far inland, high and dry. A world map no human would recognize. Not because of anything we did. Simply because the planet, over the slow grind of deep time, kept swallowing more of its water than it gave back. Now, do not lose sleep over this. If it happens at all, it is a fate that lies hundreds of millions, perhaps a billion, years away. No person, no civilization, nothing you love will ever see it. On any timescale that matters to a human life, the oceans are safe. But on the timescale of the planet itself, the timescale the Earth actually keeps, the sea is not permanent. It is on loan from the deep. And that reframes everything. The ocean is not a fixed feature of the Earth, like a birthmark. It is a balance, a temporary, dynamic truce between the water going down and the water coming up. For now, and for as long as anything we care about, that truce holds. But it is a truce, negotiated in the dark, hundreds of kilometers beneath the waves. We don't know for certain that this will happen. The deep water cycle is one of the least understood systems on the entire planet, and the numbers are still fiercely debated. But we know it is possible. And we know it has happened before, to a world right next door. Mars once had water. Real water, rivers, lakes, maybe even a shallow ocean covering much of its northern hemisphere. You can still see the dried-up riverbeds and shorelines, carved into the red rock billions of years ago. And then, slowly, the water vanished, lost to space, and locked into the frozen ground. Mars became the cold, dry desert we see today. And Venus, Earth's near twin in size, may once have had oceans too. But Venus lost its water in the other direction, boiling it away in a runaway greenhouse until nothing was left but a scorched, dry hell of a world, hot enough to melt lead. Two neighboring planets. Two different ways to lose an ocean. Both dead. Look closer at Mars, because it is the clearest warning we have. Billions of years ago, water carved deep valleys and channels across its surface, filled craters into lakes, and may have pooled into a vast ocean across its northern lowlands. Mars was, for a time, a blue and brown world with a sky and a sea. And then its core cooled, its magnetic shield failed, and the solar wind slowly stripped its atmosphere and its water away into space. What water remained sank into the frozen ground, where much of it still hides today, locked as ice beneath the red dust. Venus went the other way. Close enough to the sun that its oceans may have simply boiled, filling the sky with water vapor, and water vapor is a powerful greenhouse gas. The hotter it got, the more water evaporated, the more water evaporated, the hotter it got. A runaway feedback that cooked the planet until every ocean was gone, leaving a crushing, poisonous atmosphere and a surface hot enough to melt lead. Venus is what happens when a water world loses control of its own thermostat. 3 rocky worlds, side by side. One boiled its oceans away. One let them freeze and leak into space. And one, ours, somehow held on. The question that should keep you up at night is not why Mars and Venus died. It is why Earth, alone, stayed alive. And part of the answer may be buried 300 kilometers beneath your feet. Earth, so far, has kept its water. And it may be the deep, hidden ocean, the reservoir inside the rock, and the slow cycle that recirculates it, that has kept our surface wet and stable for billions of years, long enough for life to appear, and evolve, and eventually look up and wonder where the water came from. The hidden ocean may not just be a curiosity buried in the rock. It may be a life support system, a buried tank that has kept the surface of the Earth in the narrow, pressures band where liquid water can exist, and where creatures like us are possible. And it goes deeper than simply keeping the surface wet. Water may be the reason this planet can move at all. Earth is the only world we know of with active plate tectonics, the slow, ceaseless shifting of the great plates that carry the continents, raise the mountains, and open and close the oceans. And that motion may only be possible because the rock, deep down, is wet. Water mixed into the mantle softens the rock, letting the plates bend, slide, and sink instead of locking rigid. On a bone-dry planet, the whole system seizes up. And that is exactly what we see next door. Mars has no moving plates, just a single frozen shell of rock that has not shifted in billions of years. Earth's surface, by contrast, endlessly recycles itself. And the lubricant that keeps it moving is the hidden water. That motion runs the planet's thermostat. Plate tectonics slowly recycles carbon between the rock, the sea, and the sky, a feedback that has held Earth's climate inside the narrow range where liquid water survives, across billions of years and countless catastrophes. No deep water, no plate tectonics. No plate tectonics, no thermostat. And with no thermostat, a world drifts toward the lethal extremes of a Mars or a Venus. The hidden ocean may be the quiet engine beneath habitability itself. Think about what that means for the search for life beyond Earth. For a long time, we searched for other worlds with water on the surface, planets in the habitable zone, where oceans could sit under open sky. But we didn't even have to leave our own solar system to find hidden oceans. Look at Europa, a small icy moon of Jupiter. On the outside, it is a frozen ball, hundreds of degrees below zero. But beneath its cracked shell of ice lies a global ocean of liquid salt water, kept warm by the squeeze and pull of Jupiter's gravity. And that buried ocean is thought to hold roughly twice as much water as all the oceans of Earth. Or Enceladus, a tiny moon of Saturn barely 500 kilometers across, that shoots enormous plumes of water into space through cracks at its south pole, jets of ocean spray, escaping from a hidden sea beneath its ice. We have flown a spacecraft directly through those plumes and tasted the ocean of another world without ever landing on it. The outer solar system, it turns out, is full of buried oceans, hidden inside frozen moons that look, from a distance, completely dead. So Earth's hidden ocean is not a freak. It may be the rule. Across the galaxy, water may be waiting inside worlds of every kind, locked in rock, sealed under ice, hidden in the dark. The universe is almost certainly far wetter than it looks. And that means the places life could exist may be far more numerous than a sky full of surface oceans ever suggested. But the hidden ocean suggests something bigger. Water doesn't have to be on the surface to matter. It can hide inside a planet, woven into the rock, for billions of years. And that means there may be far more water in the universe than we ever guessed, vast reservoirs locked inside worlds that look, from the outside, completely dry. The galaxy may be soaked in hidden water, oceans inside worlds we would have written off as dead rock. And some of them, like ours, might one day sweat that water to the surface and become blue. So let's come back up. Out of the deep rock, past the ice that shouldn't exist, up through the transition zone and the hidden ocean, back through the aquifers, and out onto the shore. The next time you stand at the edge of the sea, and you look out at all that water and think you are seeing the whole of it, remember. What you are looking at is the smaller ocean. The larger one is beneath your feet. Silent. Invisible. Locked in stone hundreds of kilometers down, holding perhaps 3 times the water of every sea you can see, and quietly, over the ages, deciding whether the surface of this planet stays blue, or slowly turns to dust. We built our entire idea of this planet around the water we could see. And the whole time, the greater ocean was hidden in the dark, right under us, the largest body of water in the known universe, and one of the deepest secrets our own planet has ever kept. We have only just found it. We have barely begun to understand it. And it has been holding the world together, in the dark, the entire time. If this changed the way you see the ground beneath your feet, and the water you thought you understood, then stay with us. Because next time, we go somewhere even the water cannot reach,